Rust is not object oriented, so it doesn't have classes, but it does have structs, and structs can work similar to classes, so we can put methods and properties inside of structs and make them work similar to classes. There's a few different types of structs, and C-style structs is the one where you can give methods to. There's also a tuple struct that just takes different types like a tuple, so we can give as many different types as we want, right? Doesn't matter. We'll keep the 3. So to instantiate a tuple struct, it's pretty simple. You just create your variable, assign it the struct name, the tuple struct, and pass in the parameters. So this would be kind of useful to make stuff like this, colors. This could be, red, green, and blue, but not too useful. The most useful type of struct is the C-style struct. So here we're giving it 4 parameters. The name is a string, the age is an I32, GPA is float 32, and the major is also string. So we look at our code to instantiate it. We can instantiate that struct using it. So we make this variable s, and we're assigning it student, that's the name of the struct, and we're opening up its body. And when we do that, when we instantiate the struct, we have to provide all of its properties. So here's the name, we're assigning it Bob, and we have to cast it to a string because text like this is an ampersand stir, and our student is taking a string, so we'd have to cast it to that type. The age is a integer I32, so we don't have to cast. Float, we don't have to cast, and the major is also string, so we'd have to cast. We can print this out, and it says the name, the age, and the GPA. It doesn't print out the major because we didn't specify it here, so we can do that as well. And you access properties of the struct, as you can see, using the dot notion. So s dot, we have all the properties here. So we can print out the major as well, and we'll say IT. We can also add methods to structs to make them more useful, because it's not really useful like this, and it doesn't make much sense for us to create a struct every single time like this. It would be really nice if we could have a constructor, but Rust is not object oriented, so there's no such thing as a constructor, but we can create something similar to a constructor. To add methods to this struct and create the constructor type of method, somewhat like a constructor, we'd have to create an implementation for this struct. And to create an implementation, it's pretty simple. You just type in the impl keyword and the name of the struct you want to make an implementation for. So our struct is student, and we're going to make an implementation for it. So our implementation has 2 methods, one new and one print statement. If we're just naming it new, we can name whatever we want, but it's just convention when you making like a default like constructor for your constructor like function for your struct, you would name it new, and then it's returning a self. So self, capital S, just means student, and we could just change it to student. It makes no difference. I just like to keep it as self because I think it's easier to read. So our function new returns self, and that's what we're doing here, self, which is opening up the body. And here we're going to pass in all of our default values for it. So our student struct had all these parameters. So we're going to pass in these default values for the parameters. And so all anybody has to do is call this new method, and they would get all these values. They don't have to specify all of them themselves. They might want to keep the default values and change only the ones that they want to change, because our struct only has a few properties, but it's possible that struct has like 50 properties, so it doesn't make much sense to create this struct with like 50 different properties. So it's just better to have this one function that anyone that's using a struct can call to have the default values, and then they can change to any other values. They can change any of the values they want to. So we also have this other function here, which is called print student, and this function takes an ampersand self. When you take an ampersand self, you become an instance function. So this function is an instance function, while this function that does not take an ampersand self is a think of it like a static function. So it's not a part of the student's instance, it's part of the student's namespace. So you access it, similar to how you would access a static function in Java. So you don't have to instantiate the object, instantiate the struct to access the new. this self, you don't provide this, the implementation will provide it. So when you're calling this statement, you don't pass this self. If you want to, add parameters, you would add it normally like so. Probably want this to take it as immutable, but you would add it like so, and you would never pass this. There's no way to pass that, and you would just pass this method if you want, this parameter if you want. So if we go and look at the code of how we would instantiate that. Right here, we're making a mutable student type variable, and we're assigning it to student new. So that's how you'd access these methods that are not part of the student instance. They're part of the student's name type. Like I said, when it doesn't take a self, ampersand self, like this method does, it's not part of the instance, it's part of the type, it's part of the namespace. And now we can just change whatever we want. So we'll change the age to 10 or whatever we want, and we'll also change the major to networking, and we'll call our instance method. So if we go to the dot, and you'll see that we have this method, this different icon on it. It will tell you what type it returns to its function. So if we print this, and here we go, we get all our stuff. So the age is 10 and GPA is 4 because we kept that as the default. We changed the major and we didn't change the name. The name is also default. So it's pretty useful to create it this way instead of specifying all the types whenever you're making an instance of a struct. We can make a variable of the type of the struct we want and only change the ones we want. Maybe you just want to change the name to Billy, and we don't want to specify all the other stuff. So we don't want to do it like so and specify the age, the GPA, the major. We don't want to specify all this stuff. Our student has all this stuff right here. So maybe we want to use the students, and we can by using the dot and the name of our struct. So struct student, we have the student type. Like think of that as like the object to the student class. So this will copy everything over, a copy of it. So now it has a copy of all the stuff the student has except for the name. So we'll change the name and test that by running. And there you go. This is from the student, and this is from student 2, and it changed the name to Billy, but it kept everything else from student, and I grabbed it using the two dot student. So it's pretty useful. You can also give structs traits. These traits are abstract, so the implementation is left to you how you want to implement it. They work similar to interfaces, right? And so here we are making a trait called student major, and this trait only has one function, and it's called get major. So we're making an instance function so we can have the dot notion with it. So we can make an instance of student, say dot, and then we'll have access to this student major. Is taking a immutable reference of itself, and it's going to return an immutable string. So to implement this trait for our struct, our student struct, we do it like so: implement impl student major, the name of our trait, for our struct student. And then here is where we have to provide the implementation of the abstract method we had here, abstract function. So the header will be the same. I have to have the same header, and the body is where we would provide the body here inside of the implementation of the trait. So we're just going to return the major. That's all we're doing. And we have this ampersand here because we're not printing it. When you print, it makes an immutable borrow. So over here we have the ampersand self, but we don't put the ampersand here. We said self that major. But over here we have ampersand that's self that major. And there's really no difference. They're doing the same thing, but when you put it in a print line, it makes an immutable borrow, so it adds that ampersand by itself. So these are the same thing. But over here, when you're not printing it, you would need to explicitly add that ampersand, or you would get an error. And I don't have a semicolon or a return, but I could say return, and then I would have to add the semicolon to make it work, but you don't have to, so you can leave it as an expression, and it will note to return that because that's the last line without a semicolon, and that will be returned. Now we have access any student instance has access to this get major function, and you can test that by going up here. So you can say student dot, and there's our get major function. So that returns a take a look at it. It returns a immutable reference to a string, and we can print that as well. And there's our result networking, because the student's major is networking, which we said right here. And this student also has access. The student is also an instance of the student struct, so it has access to it. See right here, student2 dot, and has access to the get major as well, which is pretty cool. So you can use traits like interfaces to have a set of functions that everyone that implements that trait should have, and you can have standard that way. Thank you for watching. That was the end of my introduction to Rust. I think we covered most of the stuff in Rust, and in the next video we'll try to make something in Rust using what we've learned.